What is the rate of consumption of O2 gas? Now, before I give you the answer and explanation, I want you to try this question out and drop it down below. Using this chemical equation and also the fact that NO gas, its rate of formation is 0.020 m over s. Before this type of problem, we want to make sure that we recognize two things immediately, is that the coefficients under all of these reactants and the products, and also what is the rate of formation? It's molarity over seconds. So this is going to be the concentration over seconds. So when we're trying to find the rate of consumption or rate of formation of one reactant or product, when given the value of a different one, we know we have to use the relative rate expressions formula. Comparing exclusively the NO and the O2, we have the change or delta of the concentration of the NO gas over the change in time, and then it's going to equal negative of the change in oxygen gas over the change in temperature. So why is this side going to be negative? Why is the O2 side negative? Well, if we actually look at the problem, it says what is the rate of consumption of O2? And that's because oxygen is in the reactant side. So that's actually going to be the one that's consumed. So the concentration is going to be going down. Whereas the rate of formation is for NO, which means that this is going to be a positive change. Now what I also need to add is the coefficients. So the 5 for the O2 and then the 4 for the NO. Why am I doing this? Well, essentially, for each O2 that's consumed, 4 NOs are produced. So we need to make sure that our mole fractions are correct. I plug in our values. We have the rate of formation, which is molarity over seconds. So we replace this concentration and also this delta T. We still have the 4 there, equals negative delta concentration of O2 all over 5 with the times delta T. So when we solve this algebraically, we should multiply both sides by 5. When we multiply both sides by 5, we end up getting this answer. So 0.025 molarity over seconds equals negative change of the oxygen concentration over the change in time. And now all we have to do is change the negative sign from this side to that side, and the final answer should be negative 0.025 molarity over seconds for the rate of consumption of O2.